So, ladies and gentlemen, good evening. We are very tired, I know that, but I have a good news. The news is that this is the last session of the Southeast European Energy Dialogue, and it is a very, very interesting topic. It is about alternative energy sources. And always the alternative is a little bit intriguing. So it will be interesting to hear very prominent speakers. And when we refer to alternative energy, in fact, we recognize three main characteristics. The first is the potential. There is a potential. In the beginning of a new alternative, it is not very clear if this potential is enough to provoke a future paradigm shift, as renewable already did. We shall not forget that 25, 30 years before, renewable energy sources was an alternative. And now they are leaders in energy. However, there is a potential in these alternative energy sources, and this is the reason why we discuss it. And one should see if this potential will be part of our choices toward the energy transition. So the first characteristic is the potential. The second one is that every alternative energy source is put into question, and it is tested by a number of different factors, such as economic viability, synergies with other energy sectors, feasibility factors, energy security issues, social acceptance, and many, many others. The third characteristic is that alternative energy provide very, very different solutions that usually have not been tested on a large scale, and very careful planning should be done in order to integrate them into specific policies, strategies, and practices. Furthermore, allow me to say that alternative energy sources usually are connected, related to the transportation sector, as it is necessary to develop alternative sources, a part of electrification, of course, to replace conventional fuels, and actually to provide effective and viable solutions such as biofuels or hydrogen. Well, after that short introduction, allow me to present the first speaker. The first speaker is Miss Guta, Miss Liana Guta. Do we have online Miss Guta? Hello, Miss Guta. Is okay. We have the video. All right. Just to say a few words for Miss Guta. She's Director General of the European Fuel Manufacturers Association. She has served as a member of the board of directors in various organizations, including corporate entities and professional associations. And she is a partner at IENE, and she served as the chairwoman of the downstream committee. So let's hear the video, please.
Esteemed panelists, ladies and gentlemen, today I couldn't be with you in person in Thessaloniki, my hometown, as I'm on a business trip overseas, but I'm glad that the organizers gave me the opportunity to address this short recorded speech, hoping that even this way I will be able to contribute to the dialogue. I was invited today in my capacity as the Director General of Fuels Europe, which represents almost 100% of the fuels production capacity in Europe, with our members producing fuels, both conventional and renewable, as well as products used as feedstock in critical industrial sectors. Let me also remind you that liquid fuels provide 97% of the energy that moves people and goods in Europe. As for the renewable fuels I mentioned, the term refers to fuels that, based on their circular carbon cycle, do not emit additional CO2 into the atmosphere. Renewable fuels are either bio-based advanced biofuels made from sustainable biomass such as forestry or agricultural residues, municipal waste, used oils, non-recyclable plastic, or synthetic fuels, also called e-fuels, made from green electricity with captured CO2. Both options are sustainable solutions that can achieve up to 90% emission reduction. Our sector is currently in a turning point and has to address challenges like no other before in its 150 years history. Our sector fully endorsed the energy transition and the EU's ambition to achieve climate neutrality, and I have to say that it was back in 2018 when our sector presented our vision for renewable fuels and products by 2050, which means 2 years before the EU Green Deal. And then in 2020 we presented our roadmap, the Clean Fuels for All, showing how the ambition of our vision could be achieved. In the meantime, many things have changed. We now have the EU Green Deal and the huge legislative package of Fit for 55, setting and adjusting the 2030 targets. What does this legislation tell us? That renewable liquid fuels are an integral part of the European ambition and that climate neutrality by 2050 cannot be achieved without them. This is clear for the hard-to-abate sectors, aviation and maritime, where the EU legislation sets specific decarbonization goals based on renewable liquid fuels. These new technologies should be developed and the renewable products produced in Europe. This has been one of the lessons learned in the EU following the successive crises of the last few years and the international competition landscape. In this context, our sector has to address a twofold challenge. First, to remain the reliable and competitive supplier of uninterrupted, secure energy for all European citizens and businesses under all circumstances, including the next pandemic, the next energy or any other geopolitical crisis. And second, to proceed with large-scale, multi-billion investments to produce the renewable fuels that, as I mentioned, the EU will need to achieve climate neutrality. This means a monumental change of our sector, the fuels manufacturing industry, and a difficult balance that it has to strike in the transitional period. The good news is that this transformation has already started in our assets, with the conversion of conventional refineries to biorefineries, many ongoing sustainable fuels projects, co-processing of sustainable circular feedstocks in refineries, reducing thus the carbon footprint of our products, alongside investments in renewable energy, charging points, green hydrogen, CCUS. But is this enough? I'm afraid not, and the reason is that the EU legislation does not have an integrated approach regarding the transition of the liquid fuel sector, but instead focuses on specific segments of fuels that will be needed for some hard-to-abate sectors. Is it feasible to ask for renewable fuels in aviation and maritime and ignore them in all other uses, such as fuels for road transport or products needed for feedstocks for critical industries such as chemicals, pharmaceuticals, polymers? It is not, both for business and technical reasons. A sharp reduction of the fuels market, around 60–80% of the current size, will threat competitiveness and viability of the sector in Europe and will put at stake decisions for multi-billion investments that will be needed for the transformation of the sector. Moreover, a refinery, a biorefinery, or even a new Fischer-Tropsch unit producing e-fuels None of them can produce only aviation or maritime fuels. On the contrary, all of them produce a mix of products, and all these products have to find their way to the market if an investment needs to be attractive. Without the use of renewable fuels in road transport, as the CO2 regulations for light-duty vehicles and heavy-duty vehicles prescribe, the transition of liquid fuels in Europe will be at stake. On the contrary, the possibility to use renewable fuels in road transport would have multiple benefits, complementing electrification, accelerating the decarbonization of road transport for the millions of ICE cars that will still be on EU roads in the next decades, using all existing storage and supply infrastructure, offering an alternative and affordable option for all EU citizens to be part of road decarbonization, even those who cannot afford a new electric vehicle. In Greece, where we have the oldest fleet in the EU, among 27 countries, we rank last or second to last, where citizens cannot afford not only an electric vehicle, but not even a conventional new one, we should be extremely cautious to leave no one behind in this decarbonization journey. For this reason, we ask for a European strategy for the transition of liquid fuels that will address all challenges of the sector in an integrated way. The EU has already strategies on batteries, hydrogen, critical raw materials, but the strategy for the transition of liquid fuels is still missing. On the other hand, a few weeks ago, we published our strategic document ahead of the new EU institutional cycle, which we believe is more than a manifesto, this one, where we present what we can offer to Europe if enabling conditions are in place, and you can find this on our website. So, ahead of a new EU institutional cycle, we have to answer what does Europe need in the next decades when it comes to energy transition. Our sector has to play an integral role in the EU's decarbonization vision, offering solutions where other technologies stop. What do we have to offer? We support climate neutrality with our renewable fuels and products to decarbonize cars, airplanes, ships, as well as critical industries such as chemicals, pharmaceuticals, or polymers. We ensure energy security and resilience with our affordable fuels and products, today and in the future, securing our fundamental rights to move, heat our homes, but also enjoy a quality of life based on modern, high-tech products, and ensure fuel supplies for defense reasons or other unexpected crises. We are a key part of a strong EU industry creating jobs and wealth with our 95 strategic industrial plants across Europe covering our everyday needs, gradually transforming to renewable energy hubs, and these together with an extended supply network reaching every corner of Europe, fully compatible with renewable fuels, ready to be used as of today. Last but not least, our transformation will support circular economy and energy autonomy by bringing a new decentralized energy production model based on domestic and circular raw materials such as waste and residual feedstocks that will be used for the production of renewable products, paving the way to the energy autonomy of Europe. So this is our vision and our plan. Our journey, as I said, has started with multi-billion investments in renewable fuels and products, and this is only the beginning. The ambition is high and the change will be monumental. To remain competitive and make it happen in Europe, we need the EU on our side. We are ready to cooperate with the EU, member states and society to impact assess the existing regulations, suggest corrective actions and unlock technological and investment potential for a carbon-neutral future, secure and affordable for all European citizens. Thank you very much for your attention. I'm wishing you a fruitful exchange of views, and I look forward to the proceedings of the conference.
We would like to thank Ms. Guta for this video. Two topics I think that arise from this presentation. If we suppose that even in the distant future, electrification will not be able to replace at large the liquid fuels, specifically speaking about the large cargoes, airplanes or big ships such as tankers. Maybe biofuels is a realistic solution to substitute conventional fuels. The other topic is that I think that Ms. Uguta suggested that maybe in the future will be a competition between biofuels, hydrogen energy, and electromobility. And this specific topic, I would like, after your presentation, your opinion about. So let's proceed to the next speaker. The next speaker is Mr. Dr. Christos Karkalis. We have online Mr. Karkalis. Yes. But we cannot hear you.
Yes, so...
Mr. Karkalis.
Yeah. No.
Okay.
Can you hear me now?
Yes, we can hear you. The presentation was prepared by Dr. Koukouzas, but
no, I'm here because can you hear me now? Hello, good evening, everybody. So at the right beginning, I thought that I was not able.
Okay, because it was the time.
At the end of the day, I found the proper time. Unfortunately, I'm not able. I would like to apologize. I'm not able to come to Thessaloniki, but I'm in Brussels, so I have other obligations. So unfortunately, I'm not there, but I will find some time to present this work.
Okay, Dr. Koukouzas, I'm very happy that you will make the presentation finally.
Yes.
Sorry, I didn't recognize you with the glasses. So Dr. Koukouzas has a great experience. Since 2003, he's the director of CARES, the research at the Center for Research and Technology, Hellas, the Chemical Process and Energy Resources Institute. And he is scientifically responsible at over 55 EU research projects with a team of more than 40 scientists. So, Dr. Koukouzas, you have the online floor.
Yes, thank you very much. And again, apologies for not being there. I have a presentation, so I share my screen. Try to do that now. I don't know if you can see it.
Not yet. Yes. Yes, we can follow you.
Yes. Okay. Thank you very much. So I would like to be very short, as I see that we're behind the schedule. So what I'm planning to present today is about the hydrogen and CCUS application in Southern Eastern Europe. So we have one of the projects that we have. It's named Pilot Strategy Project. So I'm going to give you some slides on that. But also I give you some benefits from CO2 storage technologies and the market size. So we have the current development is that we have geological formations all around Europe, but to be suitable for CO2 storage and hydrogen storage, especially in South and Eastern Europe. We do some work through different projects. Some of them, one of them is, I mentioned to you before, is a pilot strategy with BERGEM, the French Geological Survey, and others. Another one is named SIX. So we have Horizon project doing that. Why? Because we try to find the possibility to store CO2 in Southern Europe. This is part of the development of energy transition technologies. Why we do that in Southern Europe? Because this is This is something that it's already there in Northern Europe, but we try to do that also in our place. So if for these who are not very familiar with about CO2 capture and storage technologies, I give you just only a figure here. So what we are going to do is to get CO2 from cement plant, power plants, and try to store it underground, and try to find possible geological formations like coal beds or saline aquifers or depleted oil fields or depleted gas fields. There is, I put also in this diagram salt caverns, but this mainly refers to hydrogen storage. So what we're trying to do to find, so that I put this is a map of West Macedonia, where we have, which is close to Grevenap and Dalofos Sotili formations, so where we have possibilities through this pilot strategy project, try to identify the places which are the most convenient to store CO2. And that's our work. But the future work, I think this is also hydrogen storage. This is something that is already discussed in Europe and in the United States, and this is going to be the future work for us for storage. So what we expect to have in the reservoir characteristics is that we need to find, like here we put Heptahorian Pedalophos formation, where we have a seal which is supposed to get CO2 covered underground. We try to find formations at the depth of 1,200 meters or 800 meters in Pedalophos, with a serious thickness of around 1,000 meters or 2,000 meters, 5 meters in Pedalophos, and the reservoir capacity of gigatons, as you can see here. So this is what we're trying to find. This is a typical geological cross-section where it shows the different formations, but also gives you an idea, if you go to this 5, 6, and 7, what is the sill formation, supposed to be the sealing, the cap rock, we call it, and the Heptahorian Pedalophos formation are a reservoir for CO2 to capture CO2 underground. So we have, under this project, we try to identify these places. Of course, we know, everybody, we know that Prinos also oil field is a typical case for CO2 storage. So let's go, why we would like to discuss about CO2 storage benefits now, because there are environmental, economic, and societal benefits. We're going to decrease the by 2.4 billion metric tons per year CO2. What we have is that we have capacity in the world of around 10,000 gigatons. So it's sufficient to store CO2 underground. And we have the technologies. We have capture technologies. So we're going to have 5 to 10% efficiency loss for power stations, but this is manageable to reduce CO2. We have also other, a part of the power industry, we have cement industry, steel, chemicals. So they would like to reduce also CO2 emissions by 30% by 2030. We would like to decrease almost everything from CO2 from the power plant. So this is the main, what we are trying to offer with these technologies. EOR is, as I said before, is a technology. So this is the case where we get also an extra oil from when we put CO2 underground from the oil recovery. And what this CO2 storage offers. So this is some numbers that they give in the world about CCS. So they probably create some million jobs by 2050. And we have economic benefits by of around $1.6 trillion in net economic benefits. This is some of the, also some other figures we have about the cost of storage. of around 20 to 30 dollars per ton, but the market side is enormous. It's around 3.1 billion dollars. But we have to invest also on these technologies. And now there are 65 commercial CCS facilities in operation. We expect to have some a bit more than 100 by 2030. So this is how the CO2, the carbon price is going until 2035. So what is the future of this CO2 storage? So we're going to have large-scale CCS projects all over the world, not only in Norway where we have the Northern Lights, but also in the United States, like Carbon Safe. We have Horizon Europe, so the big research program for allocated substantial funds for CCUS. We have transnational CO2 transport and storage networks, especially in the North Sea region. And then we have all this CCS role can be strengthened by the EU emission trading system. So important thing for us is the regulatory framework. So we have a directive from the European Union, but this is going to be adopted to the other member states. So this is also very important for our country, for Greece, as this is something that we need to implement to continue with CCS, CCUS technologies in Greece and in Southern Europe. So with this, thank you very much. And
thank you very much, Dr. Koukouzas. We have to say that CCS can be also combined with carbon usage, not only capture and storage. So we can use also this kind of liquid, let's say. But if you have, if we can have you with us during this panel, we can discuss it further after the other presentations. So thank you very much, Dr. Koukouzas. And let's proceed to the next presentation. I would like to present Georgios Exarchou. He is Business Development Manager at Hydrogène de France company for Greece and Cyprus. George has been involved in the energy transition across both traditional and innovative technologies in a plethora of markets, both developed and emerging, and also in Vietnam. It is a very, very interesting market. So, Yorgos, you have, yes, of course, you have the floor.
Thank you very much. Hi, everyone. Thank you very much. I would like to extend my thanks to Mr. Chairman, Mr. Stabolis. Thank you for the invitation. It's my first time participating in the event. It's been very fruitful. So I will be brief, but concise also. Hydrogène de France, so I will be speaking about hydrogen. Having seen the upstream hydrogen developments, we all know that the ESEC, NECP, for example, national plants in Greece, evolve around electrolysis, so upstream check. We've seen midstream developments, a lot of TSOs from a number of markets announced their plans and discussed their plans today on the midstream 100% hydrogen ready pipelines, etc. But what we don't hear often is the downstream segment for the hydrogen economy. And I'm glad to represent Hydrogène de France, who is involved in this segment of the hydrogen business. So on the right side, you can see in the background our multi-megawatt fuel cell manufacturing hub, which has been inaugurated last month in Bordeaux, France. So what we do, we produce fuel cells. For those who don't know, fuel cell is the technology that enables the transformation of hydrogen back to electricity. So three main markets for us: power generation, maritime mobility, and railroads across, these are the main three industries. What we do with this technical expertise, we're leveraging it through the left side, left picture that we see, where we develop, operate, and own hydrogen power generation infrastructures, acting as an IPP. We're globally present through our 5 headquarters across all continents. We have been founded in 2012. In 2019, we commissioned our first solution plant in Martinique. In 2021, we reached financial closure for one of the largest projects in the world in this configuration in French Guiana in Latin America. And the fuel cell currently is at 1.5 megawatt capacity, but it's modular. It can be less, it can be higher as we proceed. So in May 2024, we inaugurated the manufacturing hub in Bordeaux. We also inaugurated the Greek subsidiary, which I hope soon will have interesting announcements to make. And let me proceed to what we do in terms of the IPP business segment. So according, for example, to the law in Greece for strategic and emblematic investments, 4 categories of projects nowadays can be considered eligible for the qualification of strategic status. Interconnections, offshore pilot, wind, offshore pilot wind projects, electrolysis, upstream, and projects of totally controlled renewable generation. Therefore, I present the Renews table, which coincides the totally controlled renewable power generation, where what we do, we act as a baseload power plant through the long-term storage of renewable energy sources into hydrogen. The other project configuration is not currently applicable to the Greek or Balkan markets, the high power, where we connect the fuel cell to a hydrogen pipeline and we generate electricity to connect to the grid. So the Renews table is totally integrated project. What we see in the black box, it's all inside our project. So we have the solar PV, we have the electrolyzer, which produces hydrogen, we store it, and we use the fuel cell to regenerate electricity and provide to the grid. We also include a battery in this project configuration for 2 or 3 hours for peak demand reply to the grid. Our most advanced project in French Guiana is under construction. We have other projects in advanced stages in Namibia, in Mexico, in Indonesia, and Barbados. We can see on the bottom right corner that during the night hours, we operate the fuel cell system to produce what is the base load profile of the base load output of the power plant, while during the day we use the solar PV component, all through one connection to the grid, all through one PPA, all through one project combating intermittency, curtailment, energy security. We only need water, no fuel supply chain. And in comparison to other totally controlled renewable power generation like geothermal, biomass, biogas, we provide grid facilities from voltage and frequency regulation up to black start, grid formatting, and inertia as well. You can see here also that during the electrolysis and the storage of the hydrogen, we can produce excess hydrogen to use in our mobility, for example, use. Imagine a project in an island in cooperation with a ferry operator. We could decarbonize both the grid of the island, but also the transport to the shore through the maritime connection. So these are the grid services, as I mentioned already. I will not overstay my welcome. I think it has been clear, and looking forward to your questions during the event or after. Thank you very much.
Thank you very much, Mr. Exarchu. Okay, hydrogen energy is the energy of the future, they say. The problem is that many decades now, it's the energy of the future. Yeah, right. Well, the problem is that we want to see a bull market, as they say. We want to see a real revolution. There are big companies, big industries in hydrogen energy. So we have to see this revolution. It is an alternative energy that can be integrated very successful with other kind of energies. And I think that I give a very good pass to the next speaker for the presentation of Professor Vasilios Veskoukis. Vasilios is electrical and computer engineer in the National Technical University of Athens. He's professor of software engineering and geoinformation at the National Technical University. He worked as a special consultant on information systems for public and private Greek and global entities, including the Council of Europe and the World Bank. And since 2018, he works as a researcher and consultant in energy data, infrastructures, digital transformation, intelligence services for operators and major participants in the Greek energy market. So, Professor, you have the floor.
Thank you very much, Nikos. And I would also like to take the opportunity to extend my thanks to Mr. Stambolis and this great initiative. Thank you for inviting me here and giving me the opportunity to share the developments I have been involved in with you. I guess that considering the last, the previous presentation, but several others that took place today, the road has been paved for my presentation. I had prepared some introductory slides to discuss that we need to optimize what is done with rest-produced power, with power that is wasted. Maybe wasted is sort of an exaggeration, but it's kind of provocative, and it does make sense to provoke these kind of questions. So there is a big discussion, and as we heard today by my colleague, Professor Biskas, curtailments are here to stay, and they will get worse in the future. And the thing is that we need to do something with this energy. There have been several alternatives that have been discussed. Pumping was one of them. Pantelis Biskas talked about that. I will be discussing now about hydrogen, and this is an initiative that has been triggered by DEPA. I will talk about that later. So the question is whether we can optimize the revenue and minimize the rejections of renewable power by using hydrogen as storage, as energy storage. And definitely the question is about whether it makes economically sense as an investment. Nobody has shown these very specific diagrams, but they all have, all speakers have referred to periods, especially in Greece, during the last couple of months or since the beginning of the year, where a significant amount of energy that could, rest energy that could have been produced eventually was not produced, and we used energy from fossil fuels. And especially on the day of the Orthodox Easter, we could have feeded like they covered like more than half of the demand, which we did not do. And this is not just a random case that the numbers are pointing towards that direction. There are several other cases. These diagrams are from early June, I think, where the same phenomenon has occurred. I will not waste any more time explain the diagrams. I guess you can see that later. But the idea is that we have a potential that we did not use, and we do need to do something with that. This is using the hydrogen is not the invention of the wheel. As Nico said, the hydrogen has been discussed as the future of energy for quite some time. And Enzo E had very interesting event during last year. I think it was back in February 2023, about using hydrogen and producing hydrogen on site from wind generators, and either feeding it to the pipe or through a PPA to some other facility to do something with the hydrogen. And as we just have heard, there is something to be done with hydrogen. Either you use it as such or you convert it back to electrical energy. In the first case, there is like 60 to 70% efficiency, and in the latter, the efficiency is much lower. It's like 25 to 30%. I will take the opportunity of asking George about that after the presentations. So back to our questions, whether we can optimize the revenue and minimize the wasted energy from renewables. What do we need? Do we need to support some decision? And many alternatives have been discussed, but you cannot decide on what to do unless you do your maths. And what I mean by that, you need to answer specific questions. You need to see if the long-term planning of renewable energies and H2 infrastructures makes sense. And you need to analyze scenarios. You need to analyze data about that. And the same goes for building up capacity or giving incentives for new businesses. And it has been discussed extensively about the policy regulatory aspects. And last but not least, if you see that from the viewpoint of the participant, of those who who operate the plants, the renewable plants themselves, then they need to make profit. And it has to be profitable even at a private individual plant scale. In order to support the answers to these decisions, to give documentation and evidence whether to take the one option over the other, you need to do some extensive quantitative analysis. And you need to consider a lot of parameters and a lot of options and scenarios for each parameter. Either it is atomic regarding the dimensioning of investment under consideration, or a time series which involves production, how many RES plants will be deployed, and things like that. So the idea is that you need tools to collect and analyze and run specific models and customize models according to a specific environment, so as to take the best decision and to be able to support or not to support a specific investment or policy that can be under consideration. In this course, the National Technical University of Athens has taken the initiative to establish a new spin-off. We call that Hellenic Energy Competence Center. And as you can see, there are some key large participants of the energy sector, such as Mytilineos, Motor Oil, and DEPA. So the idea is to provide cross-discipline services and know-how to the energy sector. One of these projects that we have been running is the one that answers the questions, tries to support the answers and question that I have mentioned in the beginning. and we call that ECOS for Energy Clean Hybrid Storage Optimization Service, which is a software, it's a customizable scenario analyzer and optimizer for renewables with hybrid, and by hybrid we mean batteries plus hydrogen storage. This tool and this methodology is addressed to policymakers. We are already discussing for a project with RAE, and we will be able to announce something very good news briefly, I hope. And also regulators, investors, operators, every participant, every stakeholder in the renewable energy plants operation and planning. What we do is that we operate a data infrastructure of parameter and time series regarding production scenarios for existing or for future options of renewable deployments, price scenarios, which are very important, and maybe we need to integrate this work with others that assess the impacts in the prices when something of this scale, it's like 20% of the capacity that goes wasted that will be available in the market at national scale, that will affect one way or another prices. Yes, it's my last slide.
Yeah.
In order to optimize a couple of quantities, depending on what viewpoint you are standing, as you see on the slide. As I mentioned, this is offered as a software as a service. It can also be deployed locally, but the idea is that it is a tool for quantitative analysis to support or not to support options for decisions involving the use of hydrogen in as a storage for renewable energy. I guess I was very close to closing my presentation. Thank you.
Thank you very
again,
much.
And I'm available for any discussion that might.
Thank you very much, Vasilis. You gave a very comprehensive and very useful presentation. Maybe now we have a reason to install more and more renewables in the future.
And for George to sell more. Approach with the battery and the...
Yes, and we'll talk. Yes.
Well, the next speaker is Mr. Theodor Terzopoulos, a chemical engineer, gas engineer, energy and renewable gases consultant in Greece. He has worked in the gas distribution sector for 35 years, holding, between others, the position of the general manager in gas distribution department at DEPA, and general manager of strategy and renewable gases at DEPA also, and ENAM. He is also an IENE partner, and he is chairman at the Natural Gas, Biomethane and the Hydrogen Committee of IENE. Theodor, you have the floor.
Good evening and hello to everybody. We all know that Europe and Greece have taken significant steps to decarbonize the continent through a series of measures, directives, laws, studies, milestones, and also fixing quantities of alternative fuels. We also know that the energy transition in Europe is based on three pillars, which are, in few words, maximizing the share of renewable energy sources in electricity production, increasing the use of electricity for space heating, industry and transports, and maximizing the production and use of renewable fuels, biomethane, hydrogen, and e-fuels. However, I believe that the framework in which this transition will take place has been significantly affected by the economic, energy, and social impacts of the Ukraine-Russia conflict, the pandemic, and China's trade and economic policies. It is not a coincidence that the European election, the last European elections held in last June, saw the rise of far-right political forces which demonize the decarbonizing. For instance, Giorgia Meloni and Jordan Bardella have publicly stated that they oppose the decision to stop selling thermal vehicles in Europe by 2034. These changes has pushed me to summarize my today's presentation in our country's current situation and prospects for the two main renewable fuels, hydrogen and biomethane. Let me start with the key findings on green hydrogen and note that I underline that the National Environment and Energy and Climate Plan of Greece is in line with the targets and of hydrogen strategy, the European hydrogen strategy. But up to now, there is no significant market for renewable hydrogen. Although the cost of manufacturing electrolyzer has decreased by 60% during the last 10 years. Second, investor and consumer confidence remains low. Initiatives to the consumers are lacking, and the regulatory framework remains ineffective. Third, mainly due to the lack of substantial financial support for production, the price of renewable hydrogen currently ranges between 2.5 and 5.5 euros per kilo, compared with around 1.5 euros per kilo for the gray hydrogen. Here I have to say that US promotes renewable hydrogen with up to $3 per kilo tax rebate, and this is the reason why in California and in other states in the United States there is a quite good distribution line for hydrogen. Fourth, out of the 4 renewable hydrogen production technologies, seems and appears that only 2 are the most mature for the production of hydrogen, green hydrogen, and competitive prices. Fourth, the national hydrogen strategy, an essential tool for developing the hydrogen market and describing the hydrogen value chain, has not been drafted yet in Greece. Sixth, industrial uses for hydrogen in our country seem very limited. The glass and the steel industries no longer exist. The fertilizer industry cannot operate at a cost higher than that of natural gas. Seventh, the introduction of green hydrogen in the transport sector will be very complex, as the rail network in this country has only recently been electrified, and the shipping and the aviation sectors are very cautious and have other low-emission alternative fuel in mind. Eighth, the percentage of hydrogen in gas due to the percentage of hydrogen in the gas blend due to the export of the gas to the Balkan countries is limited to 2%, not more. Ninth, the compression and the liquefaction of hydrogen is a process whose cost is currently and will continue to be extremely high. 10th, the cost of using fuel cells electrical vehicles is about $0.31 per mile, while the cost for the battery electrical vehicles is around $0.022 per mile, according to data coming from California. And 11th, our country does not has a underground the possibility to store the hydrogen in underground cavities. That means that hydrogen in our country can be used in the refineries and in a second stage in some of the 220 or 250,000 trucks and 15,000 buses that are currently on road. As far as biomethane is concerned, first of all, we have to underline that no biomethane production plant currently exists in our country. Second, also, there is no legislation in place for licensing and financial support of new biomethane production plants. Third, there is a number of biogas, that means not enriched, biogas is the first type for the production of biomethane. There is a number of biogas plants for electricity production, which is, let's say, some of them, 61 out of 75 of them, are close to gas distribution networks, so it is probably financial feasible to be upgraded and to biomethane plants and to inject their production of biomethane into the gas network. But the most amazing of this table is that there are 232 already licensed units which cannot be connected to the electrical grid in Greece.
Theodore, 1 minute, please.
2 minutes, please.
Okay.
Thanks.
You have it.
Let me proceed, and in order to respect what Nico said, to my conclusions is that no one of those two renewable fuels has a positive, direct positive effect to the added value of our country's economy. As a matter of fact, this country has many, let's say, particularities. One particularity is that up to now was not able to take advantage of the technologies from photovoltaic technologies or wind technologies. To my opinion, these particularities has imposed to our country to draw its own journey toward the energy transition. And this own journey towards the energy transitions passes and is based on two pillars. The energy efficiency, which must be exploited at the maximum possible, and in this way we can save 30 to 50% of CO2 emissions, and the pumped storage hydropower instead of batteries and all those things. Saying this, speaking about the particularities of this country, I'm not saying that we have to abandon our obligations towards the renewable gases or the renewable fuels. But we have to exploit at the maximum possible way the two opportunities we have. And I repeat, energy efficiency and hydro pumped storage of hydropower. Thank you.
Thank you very much, Theodore. You presented both hydrogen and biomethane. There are very promising energy alternatives, but also you put them in a realistic basis. We don't have enough time. I would like to ask Dr. Koukouzas. Is he with us online? Dr. Koukouzas? Yes. Doctor, I would like to ask you again about the use of carbon. Can you explain us how can we use also the carbon?
You mean the CO2?
Yeah, exactly.
Yes. This another possibility, apart of the geological storage, is to produce different other chemical products like methanol. So to use it in the transport, but also I mean other sectors like in the chemical industry. So this is the main possibilities for CO2 emissions after captured with CCUS technology.
Is it possible to combine the storage and the use?
Yes, of course. Storage is only for permanent storage. So that means that we try to avoid CO2 permanently and we put it underground. There is one possibility is to get, when we use the enhanced oil recovery, is this technology means that we put CO2 underground and we get another oil production when we have the remaining of the oil deposits there. So that means that around 10% of the oil left can be also produced. So that's another thing. So we can both use CO2 in methanol or other chemicals, but also stored permanently. So this is this happens in commercial projects. Yes.
Okay, thank you very much for this answer. If you want to say something else to conclude, please feel free, Dr. Koukouzas.
No, thank you very much. I would like to thank also Dr. Sofianos and Dr. Stambolis for the kind invitation, and apologies again for not being there. Thank you very much.
Thank you very much. Now I would like to ask the speakers about what I said before. If you believe that these fuels, biomethane, hydrogen, electromobility also, are competitive or they can exist together in the same framework. So you have the floor.
Yeah, my opinion is that, yes, of course, the future stays on the renewable fuels. And the renewable fuels are three: hydrogen, e-fuels, and biomethane. My opinion is that no one of them is today and for the next few years competitive to the existing fuels. I think that we have to adopt some measures like in the States where the hydrogen is not taxed as the other fuels in order to create the market. But if we stay on what we are now, it will be very late in creating the market for the renewable fuels. This is my opinion.
Well, I totally agree with that, and I would say that scientifically and technically speaking, yes, this is the future. But what we have been witnessing during the past many years, I would say, is that we live in a balance of terror, to put it. I mean, you take one decision, and the one new investment conflicts with past investments that, like 5 or 10 years ago, you were saying that they are the future, and they still need to be amortized. And so you have a very difficult mixture that you need to address, and you need to balance a lot of things in a very delicate way. So I would say that this is a challenge, and it remains to be seen if this will be met, because scientifically and technically, yes, this is the future, but it remains to be applied. That's my opinion.
Let me add just a thing.
Can I, before you add, can I make the round?
Just to complete what I was saying, it's been 5 years now that in the States there is a reduced taxation for hydrogen. And in Europe, we just established the European Bank of Hydrogen last year, and 3 months ago, the first bid of European Bank of Hydrogen was, let's say, organized, all right? 70 million, just 70 million of loan from the European Bank of Hydrogen. So we are in delay in respect of the States. So if we keep going with this rhythm, I'm afraid that... Sorry.
I think it's a balance between technological readiness and availability of infrastructure. For example, in the shipping industry, which I follow as a fuel cell manufacturer, methanol can be used in internal combustion engines already. Nevertheless, it's a matter of availability of the fuel. European Union is strong on hydrogen as you need to have 80 kilometers in the European high roads a hydrogen fueling station. So it's a combination of technologies, a race between different options, which we're looking. And I consider myself lucky. I'm involved in the hydrogen business, but we sell electrons, not molecules, because it's still an ongoing process for the molecule energy transition colleagues. Thank you.
Thank you very much. I would like to ask the audience if you have any question. Okay. If you don't have, allow me to close this session and give the floor to Mr. Roberts to make the final conclusion and the final statement for the conference.
Thank you. No, that's all right. I can do it. It's easier doing it standing up. We had such a wide range. We had a start looking at primary energy supply and how it would go, the availability of natural gas in particular, and of course we're worried about the threats, the problems posed by both existing conflicts, the possibility of them spreading, and by financial and technical constraints. We then turned to distribution of energy. The whole question of how you've got certain systems, how do you integrate them? Today we had a good discussion on the vertical corridor initiative. Which vertical corridor initiative? The one proposed by Greece and its partners, or the one understood by Serbia? And how do they fit together when logically, unless they fit together, what the heck is the point of a partial initiative? Then you have the whole question of what goes into those systems. What is the composition of fuels? So that was very useful to discuss it. I haven't even mentioned electricity, but electricity poses many of the same issues: transporter issues, regulatory issues, and the need for improved infrastructure. And of course, it raises the issues of balance. How do you both develop the solar and the wind if you want to be increasingly using renewables, which I strongly believe we do? And if you are going to use solar and wind and biomass and hydrogen, then what kind of backup do you have in order to make sure that you can have your electricity 24/7? So we turned to things like battery storage, and of course we discussed nuclear. And that's exactly as it should be. One doesn't know which of any potential solutions will actually work out, but you have to keep pushing at all of them. So then we have the question of how much of all of this works in combating global heating and climate change? And how can we do this in a manner that is financially affordable for ordinary people? And at the same time, this poses another question. Do governments lead or do they follow? We're having a pushback against green policies, partly by governments, but also by communities. Why and how do we overcome this? Because if we don't, we know we've already are bound to exceed the 1.5 degree target, and it looks increasingly likely we're actually heading for something like more like 3 or even 4 degrees. Unprecedented. Why, and I'll just introduce a new point here. Why do we have politicians right now all over from all kinds of political persuasions that are deciding one way or another to row back on policies or pledges concerning energy use and climate change? And to do so, why do they so often effectively seem to say climate change is either not happening, or it's not man-made, or is somehow beyond our capability of managing? What they never, ever do is ask the question that I have been asking for 20 years since I first heard it in Switzerland, which is, why do insurance companies take climate change absolutely seriously? Because they have to pay out when you get climate change disasters, and that is payout after payout after payout after payout. Business understands that climate change is real, unless, of course, you have a short-term business outlook that manages to profit from contributing to climate change. So finally, I'm going to just make one short point, which is we live in a very, very uncertain world. Far more uncertain than we ever expected to be in, even a few years ago. The one thing I can tell you is that we have here and in this room some of the very best guides to take you through the dilemmas and paradoxes of this uncertain world. Thank you.
And so we have reached the end of this event, and inevitably we run out of time. But we managed to hear 55 presentations and interventions from 46 speakers in all. Now, this plethora of talks, if nothing else, helped us obtain a very holistic view of what's happening around us, at least in this part of the world. I cannot rival John Roberts in summing up the essence of this event. I have nothing more to add because he covered me fully. But I have some preliminary observations, which we will elaborate in the conclusions. And these are mostly related to the technologies. I think it has become very clear in this event that technologies have started to matter a lot. That is, we see that policymakers have become a lot more sensitive on technologies and their possible impact. So in several presentations, the technological innovation and the anticipation of new technologies was a key point. Technologies, yes, they can provide answers in many cases, and we can foresee what type of effect they could come. And we saw this very clearly also in the presentation by Ilana Guta, presentations on hydrogen in the last panel, on nuclear, with many examples. So technologies have actually started to matter and affect policy a lot more than had been happening over the last few years. And another important point is energy security, which both as notion and policy permeates all aspects of energy use and demand outlook, which is of course indicative of the highly unstable global and geopolitical environment which we have found ourselves in lately, something which also was stressed by John. So what next? Proceedings will soon follow. Over the next few days, you will receive an email with all the coordinates of where you can find the presentations and the video from this event. And I have no more things to add other than thank sincerely our sponsors, without whom we would have not been able to stage this annual conference. I'd like to thank sincerely also our staff from Sonar for their patience and support. hotel staff, and of course the IENE support team, which has helped us organize this and bring this event to a happy end, I hope. So thank you once again for your participation, and I look forward to welcoming you to one of our future events in Athens, here or elsewhere in the region. So have a good trip back home, whoever is not from Thessaloniki, and please enjoy with us a glass of wine as we go out. Thank you very much.